How does NumPy's C backend speed up Python data operations? Imagine trying to run a race with a heavy backpack on. Now picture taking that backpack off and running freely. That's similar to what happens behind the scenes with NumPy's C backend. When you work with NumPy arrays in Python, most of the heavy lifting is done by code written in the C programming language. C is a lower-level language that runs much faster than Python because it talks directly to the hardware. Instead of Python doing each calculation step by step, NumPy uses C functions that handle entire arrays at once. This process is called vectorization, and it makes operations like adding or multiplying arrays much quicker. NumPy arrays are stored in contiguous blocks of memory. Similar to how arrays are stored in C, this layout helps the computer access data faster because it reduces the time spent jumping around memory locations. When you perform an operation on a NumPy array, the C backend takes advantage of this layout to process data sequentially, which is much more efficient. It's like reading a book from start to finish instead of flipping back and forth between pages. Universal functions, or ufuncs, are pre-written functions in NumPy that perform element-wise operations. These functions are also written in C, so when you add to arrays or calculate their sign, the work is done in fast, compiled code. This means no Python loops are needed, which are slow because Python has to interpret each step. Instead, the C backend does the same job in a fraction of the time. Another way the C backend speeds things up is by avoiding Python's usual overhead. Python has to check data types and create objects for each operation, which takes time. The C backend works directly with raw data types, skipping all that checking. It's like going straight to the source instead of going through a middleman. Plus, the C code can use hardware features like SIMD, which allows the CPU to process multiple data points simultaneously. This parallel processing boosts speed even more, especially when working with large data sets. When you sum a million numbers with NumPy, it can be over 20 times faster than doing the same with a Python loop. That's big. All the work is done in optimized C code running behind the scenes. Minimizing data conversion is another key factor. When Python and C communicate, data often needs to be converted back and forth, which slows things down. NumPy reduces these conversions by keeping data in a compatible format, so operations stay quick. Finally, the C backend exposes its functions to Python through a simple interface. This means you can write easy Python code, but it runs as fast as C when you perform array operations like adding or multiplying. The C backend handles it all in a flash. This combination of optimized C code, efficient memory use, and hardware tricks makes NumPy a powerhouse for fast data analysis. So, next time you run a large calculation in Python, remember that behind the scenes, C is working hard to make it happen quickly and smoothly.